Hello everyone, a very good evening to all of you. I hope I'm audible and visible.
So yeah, hello everyone. I hope now I'm audible and visible. So yeah, hello everyone. A very good evening. I hope I'm audible and visible. If not, any one of you can confirm it. Okay. So we will start the session first. Actually, in week 11, in the last week, I forgot to tell that in the week 11, question number 6. Okay. In this question, there is a one correction. I need to do that. I forgot to calculate the overall S1. Okay, so we have calculated the covariance matrix and that I named it S1. Okay, so we have got this matrix for S1, that is 4 minus 1 minus 1, 8.8, right? So overall calculation here, this is a covariance matrix. So we have to divide it the total number of samples minus 1. Okay, n minus 1 to this matrix. So if you do that, so there are 5 samples. So here you will get 5, right? 4. So 5 minus 1 to this. If you further divide it, so you will get here 1 minus 0.25 minus 0.25, and this is a week 11 correction. Okay. In the last week, I forgot to correct it. So 2.2. Similarly, you have to calculate the S2 also. Then you need to add. So if you add these two metrics, then you will get SW overall. Okay. So I just write it here for S2 also. So the calculations are for this matrix that we have got 9.2 minus 0.2 here minus 0.2 here and 13.2, right? So if you further divide it, so you will get 2.3 here minus 0.05 minus 0.05 here and 3.3. Okay. Now SW, if you add these two metrics, that is, we know that S1 plus S2. So if you add these two metrics, then you will get here the answer 0.3 minus 0.3 and 5.5. Okay, so that's why answer is that we have got it correctly, but in the SW I forgot to just calculate here. So this is a correction from week 11, question number 6. Okay. Now today we have extra summary session. So here we will recapitulate all the week's problems, question problems mainly. I will be doing the questions here again. So that will be, I think, helpful to recapitulate or revise your questions from the previous week. So we will solve here some questions. Okay. Okay. Welcome everyone and very good evening. My name is Pooja Verma and I am PMRF Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a live and interactive session now in extra summary session. So this is our course content for all the weeks, right? Week 1 to week 12. And these are the some books and references for the this course, Computer Vision. So I hope all of you have downloaded these books and you have gone through the all the course content for over the weeks. So again, we will here do some problems. So our question number one is just any one of you can confirm me whether are you visible? Is it visible to all of you? My slides and everything?
Yes, ma'am, visible.
Okay, okay, thank you. Okay. So our first question is a grayscale image is represented using 12 bit per pixel. If the image is to be quantized down to 8 bits per pixel, how many distinct intensity levels will the resulting image have, and by what factor will the storage size in bits of the image be reduced? These are the options. Anyone have any idea for this question? This is the, I think, first big question. So just we will revise here some concepts and what we had solved in the earlier weeks. So here it is given that a gray image is represented by a using a 12-bit pixel, and if image is to be quantized down to the 8-bit pixels. So here an image is to be quantized down by the 8 bits per pixel. So total number of distinct, what should be the total number of distinct level will be there. So already we know that 2 to the power total number of distinct level, that is L. So just okay. So 2 to the power n, right? So here we have just quantized down to the 8. So total number of pixels intensity level will be this one, 2 to the power 8, and 2 to the power 8 is equal to 256, right? 256 distinct intensity level. Intensity levels. Now, next they have asked by what factor will be the storage size of the image to be reduced. So as for the storage reduction, so we have quantized from 12 bit to 8 bit. So that represent reduction by what bit? That represents reduction of 12 minus 8 bits, right? So total 4 bits per pixel. We have reduced 4 bits per pixel. So the reduction factor can be calculated as factor will be, so here that's equal to original bit minus that is that reduction bit. I can write it new bit, like, and then again original bits, and that is in percentage, so multiplied by 100. So directly you can calculate it. 12 minus 8 divided by 12, 10, so 4 by 12. So if you further just, so 1 by 300, so 33.33%, right? So the reduction factor or the storage size of the image to be reduced by 33.33%. So here 256 density intensity level and 33.33% image size will be reduced. Okay. So if you see the answer, option A is the correct answer for this question. Okay. Is it right? Okay. So have you understand this question? Can we move to our next question? Okay. So
Ma'am,
moving, yes.
ma'am, actually I was having doubt in week 10 assignment for
Week
question number
10.
6.
Okay, week 10 assignment. That assignment that you have given.
Yes, ma'am. Actually, ma'am, in that question the expected answer was visual, but my
Okay.
answer was visual in bracket group A. So
Okay.
it was means I haven't got marks for that question.
Okay. So I think one person also got the actually answer you have find the correct, but just
Yes.
check whether whatever they have given, like don't add any other extra words. Okay. So visual learning something you have also added.
Means the expected answer from their side was just visual, but my
Okay.
answer was visual in bracket group A.
Okay. So you have to give the answer, I think only visual, not a group A. So they have asked, one person also faced the same problem. So if you are, you can mail them once.
And to
Okay,
whom?
case I have got the correct answer, but I have written like this. So I got an incorrect. I didn't get any marks for that.
Ma'am, actually, I spoke with my teacher regarding this.
Okay,
She told me to wait for the explanation, and then she told me to check the mailbox. Uh,
okay. So okay, you can wait. Otherwise, I think the assignment solution has been already released for the
yes,
that assignment.
yes, ma'am.
Yeah. So what in the assignment solution, what they have given in that
They
case?
have given that the expected answer was visual.
Visual only. Yeah,
Yes,
right. Visual only.
but
So
ma'am, in that sixth question, they have basically asked which is the best effective strategy, and in that strategy table, it is written as visual in bracket group A.
that one person also faced the same
Most
issue.
effective
He
strategy.
has also find the correct answer visual, but he had written like in the answer visual learning system.
Hmm.
So he has got also incorrect. I mean, he didn't get any marks for that. So that what I have suggested to him also, you can mail them once
Ma'am, to whom?
to, I mean, that course teacher. Otherwise, you can post. I think there is a one session will be there, no, where you can post your doubt. I didn't recall that name, but let me check where you can post. So I will just give me some time. You can post that I think discussion forum. Yeah, in the discussion forum, you can ask them for that one or that question.
Okay, ma'am.
You can post your doubt in the discussion forum that I have got the correct answer for this question, but in the fill in the blank that comprehensive where we are filling the answer that I have added this one. That's why I got incorrect.
Okay, ma'am.
Hmm. So now moving to our next question. Our next question is consider a 3 cross 3 image patch that this is given as the image patch. What is the magnitude of the gradient that is g root of gx square plus gy square at the center pixel using the center pixel convention after applying the standard 3 cross 3 Sobel operator for gx and gy. So this is related to edge detection techniques that is a Sobel operator. What is our standard Sobel kernel for the vertical and horizontal and vertical direction? The standard Sobel kernel Sx and Syr. Anyone? Can you tell me what is the Sobel operator for vertical and horizontal direction? So it is a this is a kernel for horizontal direction that is -1, 0, 1, -2, 0, 2, and -1, 0, 1 again. And for vertical, this one is -1, -2, -1, 0, 0, 0, and 1, 2, 1. Right? So already image that image pixels is given 3 cos 3. Now we have to calculate first gx, this part. So for horizontal gradient, and then we will calculate the vertical gradient. So calculate horizontal gradient, that is g of x, and here we will multiply this horizontal Sobel operator with the image patch, right? So gx calculated by -1, then multiplied by 10, just row into column and this row into column like that. So here you will get, then again next one is 0. So you will get 0 here. Then next 1 into 30. Similarly, you have to multiply all the row, column for these two matrices. That is simple matrix multiplication. So -2, 10 plus 0 here you will get 2 into 30 plus -1 into 10 plus 0 plus 2, no, 1 into 30. Overall, you will get here -10 plus 0 plus 30 minus 20 plus again 0 plus 60 minus 10 plus 0 and plus 30 you will get. So if you add or subtract these values, you will get -40 plus 120. So gx overall you will get 80 here. 80. Similarly, we have to multiply gy also. Multiply this Sobel operator, vertical Sobel operator to the image patch, and then you will get the vertical gradient gy. Okay, so I'm just removing it from here to calculate this value. vertical, that is gradient gy. Okay, similarly, again we have to multiply this to this one. Here our minus 1 into 10 plus, I'm just not calculating for the 0 one because all values will be the 0 only, minus 2 into 20 plus minus 1 into 30, right? Plus again 1 into 10 plus 2 into 20 plus 1 into 30. So here you will get minus 10 minus 40 minus 30. Here again plus 10 plus 40 plus 30. So all will be the cancelled out, right? Here. So we will get 0. So that means gy you are getting 0 here. And now, so the overall magnitude of the gradient g is calculated by root of gx square plus gy square. So gx square is 80. 80 square plus 0 square. Overall you will get here 80 square. So 80 you will get. So option C is the correct answer for this question. Okay. So I think these are the basic questions. So you all are getting these questions. So to moving to our next question. Our next question is the median filter is a nonlinear special filter often used for noise reduction. What type of noise is the median filter particularly effective at removing and why? Option A, Gaussian noise because it calculates average intensity spreading the noise evenly. Option B, uniform noise because it uses the complex kernel to model the noise distribution. Option C, salt and pepper noise, or also called as impulse noise, because the median operation ignores extreme isolated intensity values. Or option D, structural noise, because it is an adaptive filter that changes its kernel based on local image texture. So any one of you have any answer for this question? Which option can be a correct one? Please try to answer this question. The median filter is a nonlinear special filter often used for noise reduction. And what type of noise is the median filter particularly effective at removing and why? Okay, so let's see the solution. Here the solution is here. The median filter is particularly effective at removing salt and pepper noise, that is impulse noise, because the median operation ignores extreme isolated intensity values. Okay, so why the median filter works for the salt and pepper noise? First, we will see what is a salt and pepper noise. So basically, this type of noise appears as random, isolated dark or bright pixels that is scattered across an image. Okay, so if there is an 8-bit digital image, would be some pixels posed to the maximum value is 255, that is a salt noise at that, and the other to the minimum value, that is 0, and this is at 0 there is a pepper noise, and at the maximum intensity value or the maximum value of that, so there is a salt noise. Okay, so for 8 bit, if there is a, so we know that 2 to the power 8 different intensity values are there. So 256 so there that will vary 0 to 255. So 0 is the our minimum value and 255 is the maximum value. Okay, so this is called pepper, and at the highest value that pixel goes to the that is a salt noise. Okay, so our next, how does this median filter remove it? So the median filter basically works by using the kernel, that is also that can be any 3 cross 3 or 5 cross 5. Any kernel you can take a small window of the pixels that moves over an image, that will be the move over an image. For each pixel it sorts and intensity value at all the pixels within the kernels and replace that center pixels value with the median value from that sorted list. Okay, so already you have been, I think, calculated or studied, or there is a image pixels are given as a 3 cross 3, either 5 cross 5, and there is a one kernel that there will be given. We will just move in and calculate the median value on that and replace with the median value of that pixel. Okay, and also it helps to ignoring outliers. So because the extreme values of the salt and pepper noise are sorted to the very beginning or the end of the list, they are simply ignored by the median value, and the new pixel value will be instead derived from the surroundings and uncorrupted pixel, effectively eliminating that noise. Okay, so why other options are incorrect? The first one is Gaussian noise. So Gaussian noise, already you have seen that this is a continuous random noise that affects every pixel, not just isolated one. So a mean, that is a Gaussian filter, will be generally better at handling the Gaussian noise. That mean or average filter, you can say that. That Gaussian noise, because it averages out of the subtle fluctuation, although it tends to a blur edges. So when we will use the mean or average filter to remove the Gaussian noise, but there is a blurring effect from the in the image, we will find out. So a median filter would not be ideal because it removes actual image details along with the noise in the area where gradually intensity changes. The another one is uniform noise. So like Gaussian noise, uniform noise is also affected all pixels randomly, but that uniform probability distribution with the uniform probability distribution. So while median filter can reduce this, but the midpoint filter often works better because it effectively finds the midpoint of the uniformly distributed pixels. Okay, and the another one is structured noise. So this includes the periodic pattern caused by the electrical or scanner interference, and the median filter is not just the choice for that. So these patterns are best addressed in the frequency domain using the filter that target specifically frequency of that noise. So median filter basically particularly effective to remove the salt and pepper noise because the median operation ignores the extreme isolated intensity value. So option C is the correct answer for that question. Okay, okay. So already given. So we will move in to our next question. So our next question is a point to one is mapped using homography matrix. That is, homography matrix is given. What is the transformed point for this? So would you like to answer for this question? At least try to answer for this question. So a point is given. What we need to do? This point first we need to change in the homogeneous coordinate. Right? First we need to convert it into a homogeneous coordinate. So how we are converting it? Given point, so this point is given, that is a 2, 1. So first we need to convert it in homogeneous coordinate. So what you will get here after converting the homogeneous coordinate? Can you just tell me what you will get here? So just we are adding 1 as a third coordinate. Okay, and homography matrix is also given. Now how we can transform it? So to transform that point, the given point, we have to multiply this point, let's say P into H, right? So let's say it is a P dash. So P dash is X dash, Y dash, Z dash, this is the direction, and here first homogeneous matrix, our so H into P. It is basically so 2 0 1 0 1 1 0 0 1, right? It is given here. And our point given point is 2 1 1. Simply we need to multiply these two. So 4 plus 0 plus 1, right? Now next row 0 plus 1 plus 1. Next row to this one. So 0 plus 0 plus 1, right? So here you will get here 5 2 1, right? So the transform point that you have got, that is x dash, y dash, z dash. It is in the homogeneous coordinate system. Now convert back to the normal point. Convert back. So what we are doing, just dividing by the last coordinate to the this one. Overall you will get 5 2 if you convert back again. So what point you have gone? The transform point is 5 2. So option A is the correct answer for this question. Okay. So is it fine? So are you able to recall all those things? See, I hope all of you are just recalling all those concepts and points. So moving to our now next question. Now next question is given two 2D points in homogeneous coordinates. So these 2 points are given, that is x1 1 2 1 transpose and x2 is 3 4 1 transpose. Calculate the homogeneous coordinates of the line L connecting to them. Now we need to calculate the homogeneous coordinate of that line that is connecting these two coordinates, 2D points, or you can say that. So how we can calculate this one? The line connecting these 2 points, connecting these two, can say 2D points, that is x1 and x2, is calculated by their cross product, right? Their cross product, right? That is L x1 cross product with x2, right? So how we can calculate the cross product of these two lines? So already you know that calculating the cross product, of these two lines. So you can just simply 1, 2, 1, that first one x1, and now x2, 3, 4, 1. So just calculate it I. So 2 minus 4 minus of j here. So cross multiplication of these two, 1 minus 3 plus k 4 minus 6, right? So here we will get minus 2i plus 2j minus of 2k, right? So overall, with respect to all these values, so you will get the point of minus 2, 2 and minus 2, right? You can write transpose also. So this is the homogeneous coordinate, that line connecting to these two points. If you see that option B is matching with this answer, so option B is the correct answer for this question. Okay, so this is the coordinate points that connecting these two 2D points. Okay, so I hope all of you are understanding these questions, or are you able to recollect or remember these points? So moving to our next question. Now next question is, the focal length is 20 millimeter and real world object height is 100 millimeter. Distance from the camera is 1000 millimeter. What is the image height? So this question is related to camera geometry, I think, right? So the how we can calculate the image height? So the image height is calculated by, let's say image height is that calculated h dash. It is calculated f into h by z, where f is our focal length, and h is the real world object height here, object height, and z is the distance from camera. So this is a direct formula based question. Just you need to put in this formula, you will get the image height. So h dash is f is 20 millimeter, object height is 100, and it is 1000, right? So if you just get, you will get 2 millimeter. The image height is 2 millimeter. Okay, so you can see that option A is the correct answer for this question. Okay, is it fine? Are you getting these questions? Are you able to recall? Okay, okay. So moving to our next question. Now, next question is, which set of parameters is coded in the 3x intrinsic camera matrix K of the pinhole model? So option A is rotation and translation of the camera relative to the word frame. Option B, radial distortion coefficient, that is K1, K2, then Kn it can be. Option C, depth Z and baseline B of the stereo pair. Or option D, focal length, fx, fy, principal point, and skew. Which set of parameters is encoded in the 3x3 intrinsic camera matrix K of the pinhole model? So would you like to answer this question? Then we will discuss it in detail. The detailed solution is here. We will discuss it. Anyone try to answer for this question? Okay, so let's see the detailed solution. Each set of parameters is encoded in the 3x3 intrinsic matrix, camera matrix C of the pinhole model. So here we will just discuss by go through the options. So option E is rotation and translation. So the rotation and translation describes the camera's extrinsic parameters, not the intrinsic. So it defines the camera position and orientation related to the word coordinate system. That rotation and translation will describe the camera's position related to the word coordinate system. So the intrinsic coordinate matrix only deals with the internal properties of the camera, not the extrinsic parameters. Now next one is a V radial distortion coefficients. So these parameters are used to correct for the lens imperfections that causes straight lines to appear curved. Okay, so this is also not related to camera's intrinsic matrix, and this is also a internal camera property, but this is not handled separate, and this is handled by separately, not a part of a standard intrinsic matrix. Now next one, depth and baseline of the stereo pair. So depth is the measurement of the distance, not a camera parameter, and the baseline is the distance from the two cameras in the stereo setup, which relates to their extrinsic parameter, not a intrinsic parameter. Now next one will be focal length, that is fx, fy, and principal point and skews. So this is a correct set of parameters for the intrinsic matrix. So firstly, focal length. So the focal length expressed in the pixel for the horizontal and vertical directions, and the principal points that represent the coordinate of the image optical center, which is the intersection of the optical axis with the image plane, and skew defined by a parameter that represents the non-perpendicular polarity of the sensor's x and y pixels axis. For the most modern digital camera, that value close to zero, but this is the internal part of the intrinsic matrix. So the correct answer is D. The 3x3 intrinsic camera matrix K of the pinhole model encodes the camera's focal length, principal point, and skew. Okay, so option D is the correct answer for this question. So now moving to our next question again. Our next question is the fundamental matrix F relates the corresponding points into images. Which of the following statements about F is correct? Option A, it is a valid only for the calibrated stereo system. Option B, it directly encodes the rotation R and translation T, which should be capital, between the cameras. And option C is it is a 3x3 matrix with 9 degrees of freedom. Or option D, it has a rank of 2 and can be calculated from the minimum of the 7-point correspondences. Which statement is true about fundamental matrix F? Can you answer for this question? Please try to answer for this question at least. so nobody is interested to giving answers. Okay, so let's see the detailed solution for this one. So explanation, detailed explanation is headed here. So I will go option by option, then we will see. Okay, which option is the correct? So option A is it is valid only for the calibrated stereo system. So fundamental matrix describes the epipolar geometry for the uncalibrated cameras, as we know that. So it does not require the knowledge of the camera's internal calibration parameters like focal length, principal axis, or skew. Already we have seen in the previous question. So this is a primary distinction between the fundamental matrix and essential matrix C, which requires calibrated system. So this statement is correct regarding to the fundamental matrix in that case. So our next option is it directly encodes the rotation R and translation T between the cameras. So this statement describes the essential matrix which relates corresponding points in a calibrated system and can be decomposed into a rotation and translation. While the fundamental matrix is related to rotation and translation, but it also incorporates the camera's intrinsic parameters, therefore does not encode the rotation and translation directly. So it is also the incorrect statement for this one. Our next statement is it is a 3 cross 3 matrix with 9 degree of freedom. So while F has a 3 cross 3 matrix with 9 elements, it only defines only up to a scale factor, that reducing its degree of freedom to 8, right? If there are 3 cross 3 matrix, that means 9 elements. So there are total n minus 1 degree of freedom. Already we have solved that type of question in the during the week assignment problem. So you can see that here only 8 degree of freedom will be there. So further it has rank of 2, meaning its determinant will be the 0, which removes the additional degree of freedom, and this leaves the fundamental matrix with the total of 7 degree of freedom in that case. Okay, so this is also incorrect. The 3 cross 3 matrix with 9 degree of freedom is not a correct for that in that case. So our next option is it has a rank of 2 and can be calculated from minimum 7-point correspondence. Okay. So the fundamental matrix S is a 3 cross 3 matrix. Already we have seen in the previous statement that is a singular, meaning its determinant is 0. If 3 cross 3 matrix is singular, in that case our determinant must be a 0 and that will give rank of 2 of that matrix. Okay, and this is because maps a point in a line, that epipolar line, which is projection from 2D space to 1D space, and therefore not a full rank transformation. So calculated from the 7-point correspondence, that means because F is a 3 cross 3 homogeneous and determinant of that 0, it has a 7 degree of freedom, that is 8 independence ratio minus 1 constraint. Okay, so that means only at least 7-point correspondence are necessary to determine the fundamental matrix. So that's why the correct statement is fundamental matrix has a rank 2 and can be calculated from minimum 7-point correspondence. Okay, so option D is the correct answer for this question. Okay, so I hope all of you are able to recall these points and these things. So we will moving to our next question now. Our next question is a rectified stereo system has a baseline that B is 0.5 meter. Focal length f is 1200 pixels. If a feature point is observed with horizontal disparity, that d is equal to 30 pixels, what is the approximate depth, that is z, of the corresponding 3D point? So any one of you are able to recall how to calculate depth from the of the corresponding 3D point from the given data. What is our that formula? The depth formula for the rectified stereo system. Okay, so let's see. So the depth Z is is calculated by that is Z is equal to F V divided by D, where F is already we know that there is a focal length, B is the baseline of that stereo system, and D is the disparity, right? Already all values are given. So just put in this formula. So this F is a 1200 pixel, B is given as 0.5 meter, and disparity is given as 30 pixels, right? 30 pixels. So just divide it. So you will get here 20, right? So 20 meters. But pixels and pixels will be cancelled out, only meters will be there. 20 meters. So the approximate depth Z of the corresponding 3D point is 20 meters. Okay, so here if you see that here option D is matching with the answer. So option D is the correct answer for this question. Okay, so okay. Moving to our next question now. Next question is which of the following is the key reason why shift, that is scale invariant feature transform features are robust to changes in image orientation, that is a rotation. Option A feature detection process uses the Laplacian of Gaussian, that is logi, which is a inherently rotation invariant. Option B is the matching process uses the cross correlation coefficient, which is rotation invariant. Or option C is the descriptor is computed on a spherical coordinate system, not a planar one. Or option D, a dominant orientation is assigned to each key point and descriptor is calculated relative to this single angle, this one. So which option can be a correct one for this question? Anyone? Okay, so let's see our detailed solution here given here. So I have added in a detail all the solutions so that you can able to recall the previous point, the previous week question from the previous week questions. So explanation is added here. The shift algorithm detects key points and compute their descriptors through several steps, as we know that, which together make the features robust to change in scale, rotation, and illumination. So the key steps that explain the correct answer are, so first one is in the shift operation. First one is a orientation assignment, and next one is descriptor generation, right? So first in the orientation assignment, the shift identify a region around each key point and create a histogram of the gradient orientation for that pixel in that region. And that peak of this histogram represents the dominant orientation of the key point and which is assigned to it, to the orientation assignment. Okay. Now next process is descriptor generation. So to achieve the rotation invariance, all the gradient orientation and coordinates used to create a descriptor and rotate it relative to the key point's dominant operation, and that means regardless of the image overall rotation, the descriptor is always computed from the consistent frame and references. that make it ideal for a given feature no matter its orientation. So the other options that are given, option A is the feature detection process uses the Laplacian of the Gaussian, which inherently rotation invariant. So shift in the shift of approximation, the LOG with the difference of Gaussian to detect key point that are scale invariant. Okay. So while DOG is the also rotationally symmetric, it is only part of the process, does not fully count the rotation invariance. So that explicitly orientation assignment to the key step of handling rotation DOG. Okay. And in the next option, that in the matching process is the cross correlation coefficient, which is the rotation invariant. So shift typically uses the Euclidean distance to compare feature vectors for matching, not a cross correlation. So the rotation invariance is embedded in the descriptor creation, but not a matching algorithm itself. The next option is the descriptor is computed on the spherical coordinate system, not a planar one. So this is also incorrect description of how the descriptor is created. So the shift descriptor is based on the 2D spatial histogram of the gradient orientation within the focal local patch around the key points. So with the orientation explicitly normalize the relative dominant angle. Okay, so correct answer is D. Shift achieves the rotation invariance by assigning the dominant orientation to each key point and then computed the descriptor relative to that orientation. Okay, so this is the correct answer. A dominant orientation is assigned to each key point and the descriptor is calculated relative to this angle. Okay, so because the shift algorithm follows basic these two means orientation assignment and descriptor generation. Okay, so I hope all of you getting these questions. Now moving to our next question. Now next question is related to Harris corner. The question is given as Harris corner response is given by this R is equal to determinant of M minus K trace of M whole square. For the given data is given, the M matrix is given, K value is given. Now we need to calculate this R. Okay. So already formula is given, values is given, just you need to calculate first the determinant of M and the trace of M and put in that equation. So can you calculate at least for this question? Can you calculate what will be the determinant of M? So what is this determinant of this matrix? This one. Okay. So this is simple multiplication of these two. So 12 minus 1. So determinant of M is 11 here, right? And what is the trace? Trace of M? This is these two values. These two. This is diagonal values of that matrix, right? 8. Okay. Just a minute. I will present. Okay. So now it's visible to all of you. Are you able to see the slides and everything? Okay, so trace of the matrix is this diagonal matrix. So just addition of these two. So 4 plus 3. So trace of M is 7. Okay, now put in this equation, that is R determinant of M minus K into trace of m whole square. So determinant we have calculated 11. K is given at 0.05 and trace is 7 square, right? So 11 minus, you just multiply 0.05 multiplied by 49. So here you will get 11 minus 2.45. So overall value you will get 8.55. So is that direct correct? So the value you will get 8.5. So just choose the closest. If you see that 8.2 is the closest value with this one, right? 8.2 is the correct answer for this question. Option A. Closest value, or you can say that closest option. Check for the closest option. So 8.2 is the closest. So 8.2 is the correct answer for this question. Okay. Okay. So moving to our next question. So next question is cluster centers, like given as 2, 2 and 5, 5. Data point is 3, 4. Which cluster is it assigned to? This data point, which cluster in between these two cluster center, which cluster center it will assign. So can you tell me at this the given data point, which cluster it will be related to? So what we need to do for that? We have to calculate the distance between these two clusters. Which cluster find the nearest one, that will be assigned to that cluster center, right? So let's check the this data point, distance to data point, distance to first for 2 to that we need to calculate for 5, 5. So how we can calculate? So given data points is 3, cluster center point is given 2 square plus again 4 minus 2 square, right? So here we will get 1 square plus minus of 2 square. Overall get here 1 plus 4. So the value you will get root of 5. And root of 5, if you calculate that, you will get 2.23. Similarly, we have to calculate the distance from the 5, 5, the center point cluster center 5, 5. So root of 3 minus 5 plus 4 minus 5 whole square, right? So minus 2 square plus minus of 1 square, here you will get. So again we will get 4 plus 1 and overall value you will get 5. So again 2.23. So both values are equal or similar, you can say that. So you have find the equal distance. You can say that equidistance. It is also known as the equidistance. That means from this data point, the both the cluster center have a equal distance. So in that case, we cannot say. So we can say that if it is in the option, equidistance is the option. So this is a best option, correct answer for this question. Okay. Option C, equidistance for this question. Okay. So this is from the clustering, that clustering and diamond classification, I think from that week. So are you getting these questions? Is it helpful to recall all the concepts and the questions related to that? Okay, okay, Swati. Okay, so moving to our next question now. Now, next question: why is the HSV, that is hue, saturation, and value color space generally preferred over RGB space for tasks like color-based image segmentation? For example, finding all red objects. Option A: HSV requires less memory to store color data than RGB. Option B: HSV uses the fewer channel, making computation faster. Or option C: RGB is subtractive model while HSV is an additive model. Option D: the hue component is perceptually decoupled from illumination intensity. So, anyone? Why is the HSV color space generally preferred over RGB space for the segmentation task? Anyone? Any idea? Okay, so let's see the solution for this one. So here we will go option by option. So HSP requires less memory to store color data than RGB. So this is incorrect because both HSP and RGB typically uses the three channel model and that requires the same amount of memory to store the color information. So this is the incorrect statement that both the color models or color channels are required the same amount of memory. Okay. Now next option is HSP uses fewer channel making computation faster. This is also incorrect because both HSP and RGB uses the three channel again. In fact, converting an image from the RGB to HSP for processing adds a computation step, so which is a trade-off from the improved color robustness. Okay. Next is RGB is subtractive model and HSP is additive model. So this is also incorrect because the RGB color space is an additive model, in fact, and adding the different intensity of red, green, and blue light produces other colors. And the HSP model is a cylindrical coordinate representation of the RGB color space. So that does not a different mixing model that does not consist any different mixing models. So a subtractive model is CMYK, that is cyan, magenta, yellow, or black, or you can say T is used in printing. So RGB is a additive model and this is a subtractive model CMYK. Our next option is the hue component is perceptually decoupled from illumination intensity. So this is a correct answer because the hue channel represents the pure color itself, which remains relatively stable even as the lighting or intensity of a scene changes. Shadows highlights the different light sources affect the value, that is brightness channel, but they don't significantly alter the hue. So in contrast, changes in illumination cause all the three RGB channels to shift unpredictably, making color-based segmentation in RGB far less robust. Okay, so option D is the correct answer. The hue component is perceptually decoupled from illumination intensity, and all other statements are incorrect already. We have described it. Okay, moving to our next question now. Our next question is the key means clustering algorithm aims to partition n data points into k clusters such that the objective function is minimized. Which of the following correctly describes the objective function for k means? Option A: maximize the distance between the k cluster centroids. Option B: maximize the distance between each point and its assigned cluster centroid. Option C, minimize the difference between the largest and smallest eigenvalue of the data covariance matrix. Or option D, minimize the within cluster sum of squared or the sum of squared including distances between each point and its cluster centroid. Which option is correct for the k-means clustering algorithm that aims to partition n data points and k clusters such that objective function is minimized? So, which of the following statements correctly describes the objective of the k-means clustering algorithm? At least try to answer for this question. Anyone? Okay, option D. Yeah, you are correct. In the k-means clustering, what we are doing? We are minimizing the within cluster sum of square or within cluster distance by including distance between each points and the centroid, right? So here the detailed solution is explanation is added here. In the k-means clustering algorithm, iteratively assign data points to the clusters and update cluster centroid with the goal of maximizing the total square distance between each data point and the centroid of its assigned cluster. So this is done by square including distance that is precise within the cluster sum of square. That is this one, the total number of clusters and the points x minus that mu I is the mu I is the centroid of the cluster Ci. Okay, so option D is the correct answer. Minimize the within cluster sum of a square or the sum of a square excluding distance between each point and its cluster centroid. Okay, okay, so now moving to our next question. Our next question is, what is the primary motivation for using parameter sharing, that is using the same kernel across the input in the convolution layer of a deep neural network, or you can say that CNN, convolution neural network? Option A, to increase the network's ability to model extremely complex nonlinear functions. Option B, to ensure that network processing is insensitive to image resolution. Option C, to increase the depth, that is number of layers of the network without causing the vanishing gradient problem. Or option D, to drastically reduce the number of learnable parameters and provide translation invariance or equivariance. Answer for this question. What is our primary motivation for using parameter sharing in the CNA, or you can say in the convolution layer of the deep neural network? Okay, so let's see the solution for this question. So the primary motivation of parameter sharing in convolution layer is that option D is the correct answer, to drastically reduce the number of learnable parameter and provide translation invariance. So this core design feature makes CNN higher effective for image processing tasks. So what is our motivation to share the parameters in the convolution layer? So our first motive, reduce number of parameters. So instead of each neuron is in a convolution layer having unique set of weights, a small filter, or you can say that kernel with a single set of weights is split across the entire input. So this drastically cuts down the memory and computation requirement, making it feasible to train and run large network on a high resolution images. And next one is a translation equivariance, right? So by using the same kernel across the entire image, the kernel can detect the same features that, for example, edges and a specific texture, regardless of where it appears in the input. So if the input feature is shifted, its representation in the feature map will be shifted accordingly also. So this property allows the network to recognize an object even if the position within the image changes. Okay, so option D is the correct answer for this question. Okay, so these are the two primary motivation of using the parameter sharing, that is using the same kernels across the input in the CNN. Okay, so I hope you have understood this explanation. So now moving to our next question now. Our next question is, when comparing the inference speed and model complexity of the three core tasks, that is, which sequentially correctly orders from the last least complex and fastest to the most complex or slowest. Option A, semantic segmentation, object localization, and instance segmentation. Option B, object localization, instance segmentation, object recognition. Option C, object recognition, object localization, instance segmentation. Or option D, object recognition, semantic segmentation, and object localization. So when comparing based on the inference speed and model complexity of these code three tasks, so which sequence correctly orders them from the least complex, or you can say fastest, or to the most complex or slowest. That means fastest to slowest. So anyone have any idea? Would you like to answer for this question? Please try to answer for this question. It is the fundamental application based question on the object recognition, localization, and segmentation. Yeah, got the correct option C. Because in the object recognition, only in the image we are recognizing which image it is belongs to, and in the object localization we are localizing that object with bounding box. So that means this is a little bit complex than object recognition. And instance segmentation, what we are doing, we are actually labeling the pixel wise segmentation. That means just we are doing the pixel wise segmentation or pixel wise labeling. So this is the most complex and the most slowest when we are comparing in terms of inference speed and model complexity, right? So solution is added here. So correct answer is C, object recognition, then localization, then instance segmentation. So in the object recognition, or we can say classification, also requires the least effort. Outputting the single label, it needs only global feature, does not require any other. So already we have seen in the previous class, okay, there is a one image, that is the input image. Two dogs are there. So here just we are output dog. There is a where it is, what they are doing, that does not matter to us. Okay. So just recognizing what object it is. While in the object localization, or you can say object detection, adds the complexity of the reducing four bounding box coordinates, because we are making the bounding box like this. So there are four coordinates are there, right? So it requires localized feature where it is. So their coordinates, x, y coordinates, we are required. So it is a little bit complex. It added that much of complexity by recognizing the object. While in the instance segmentation, what we are doing? So the most demanding task it is, because it requires the localization step, that means bounding box position plus generation of high resolution pixel accurate mask for every object instances. So here you can see that here we are just making a bounding box, but here we are doing the edgewise where it is how it is moving. So it requires a much more complex. So when it is complex, so it makes slowest or most computationally intensive when we are comparing in terms of the inference speed and model complexity. Okay, so option C is the correct answer for this question. Object recognition, then object localization and instance segmentation. Okay, so is it okay for you? Anyone? Can we move to our next question? Okay, so I hope we are getting, so now moving to our next question. So our next question is, if an octave in a shift operator is constructed to contain S is equal to 6 distinct Gaussian blurred images, that is scale, what is the constant scale factor k by which the standard deviation sigma of each image differs from the next image? Round off answer to the three decimal place. That is okay. So if an octave in a shift operator is constructed to contains S is equal to 6 distinct Gaussian blurred images, what is the constant scale factor k by which standard deviation sigma of each image differs from the next image? So how we can calculate this one? So already we know that within octave the adjacent scale differs prime by a constant factor k. If an octave, so I'm just writing here, within octave, just a minute, within octave the adjacent scale differs by a constant factor k if an octave contain contains s plus 1 measures, right? So then the constant scale factor then k is calculated by 2 to the power 1 by s, right? Already you must be solved this question, this type of question in the previous week question answer session as well as your assignment problems also. So here s is equal to 6 is given, but it is not that. So basically it contains s plus 1, right? So overall event s minus 1 to calculate this one. So 5 will be there, right? Because in the octave it is contained s plus 1 image. That means that this s plus 1, that this is given s plus 1 is 6. So to find out s, 6 minus 1 will be the 5. Okay. So the scale factor is 2 in an octave. So therefore k is equal to 2 to the power 1 by 5. So if you calculate this 2 to the power 1 by 5, you will find the 1.14869 value. This is a value of 2 to the power 1 5. So if you just approximate it, you will get 1.149, right? So if you see that, option D is the correct answer for this question. Is it fine for you? Anyone? Any doubt? Anything? Okay, so moving to our next question again. A convolution layer takes an input feature map of size, that is size of the input feature map is 56 cross 56 cross 128, that is the height, width and channel. It applies a total of F out, that is F out has to 256 filters of size K, 3 cross 3 with a stride S is equal to 2 and 0 padding P is 1. What is the resulting output feature map size O cross O, that is output cross output F out total. So how we can calculate the output size O? So already you know that formula. The output size is calculated by size O is calculated by this formula, right? I minus K plus 2P S plus 1, where S is stride, I is the input, right? K is the filter size and P is the padding filter size. So everything is given. Input is 56 cross 56, so only 56 we will take here to calculate further. So we can just adding that one. So 56 minus K is 3 plus P is given. So 2 into 1 divided by S is given 2 plus 1, right? So here you will get 56 minus 3, 53 plus 2 divided by 2 plus 1. Overall you will get here 55 divided by 2 plus 1. Here you will get 27.5 plus 1. So it we can write it 27 approximately plus 1. So here you will get 28 if you just with this sign. So 28. So our output size will be 28 multiplied by 28. F out how much? 256, right? So the output feature map dimension will be the 28 multiplied by 28. The depth channel is already given of the output is equal to the number of filter used in the F out. Okay, so this is our overall answer. 28 multiplied by 28, 256. That is, which option is correct? Option C is the correct answer for this question. Okay, is it fine for you? Need out anything? No, I think so. Moving to our next question. Now our next question is given two feature vector A and B, each of size 4. A is given as 8241 and B is given as 5613. Now we need to compute the L1 norm by the Manhattan distance and L2 norm by equilibrium distance between A and B respectively, and round off L2 norm by two decimal places, that is fine. So already we know that how to calculate the Manhattan distance, that is also used for L1 norm, and equilibrium distance, the points are given. So L1 norm is calculated by, let's say, is the sum of the absolute differences between the corresponding feature vector. Feature vector. So L1 is summation of ai minus bi. So just we have to calculate all the 8 minus 5, right? Plus 2 minus 6 plus 4 minus 1 plus 1 minus 3. Absolute differences between the these vector and sum of all that absolute differences. So 3 plus minus of 4 plus 3 plus minus of 2 here we will get. So this is the absolute difference. So if you just there is a no minus sign will be there. So 3 plus 4 plus 3 plus 2. So if you add all those things, so you will get 12 here. Similarly, L2 norm here it is defined as we have calculated the Euclidean distance, right? The square root of the square differences between the feature vector. So this is the summation of our all squared root of these two feature vectors. So similarly, we have to calculate again for 8 minus 5 square plus 2 minus 6 square plus 4 minus 1 square plus 1 minus 3 square, right? So again here you will get 3 square plus minus 4 square plus 3 square plus of minus 2 square, right? So root of 9 plus 16 plus 9 plus 4, right? So if you just add all these values, so you will get 38 and the root of 38, you will get value of 6.16. Okay. So if you see that the L1 norm that we have got 12 and L2 norm that we have 6.16. So if you see match with the option, so option D is the correct answer for this question. Okay, so I hope all of you have understand this question. So now moving to our next question again. Now our next question is related to Kullback-Leibler divergence theorem. So it is given as find the Kullback-Leibler divergence theorem, that is DKL PQ, between the true probability distribution P and the estimated probability distribution Q, where the distributions are defined over the three discrete events. So three discrete events for P and Q is given as, so round the answer to three decimal places. Okay, so how we can calculate the Kullback-Leibler theorem or KL divergence? So basically the KL divergence measures the information gain of if Q were used to approximate the P, and the formula for the discrete probability is, so we can write here the KL divergence, that is P KL calculates the information gain if Q were used to approximate P, and it is given by this is the formula P KL P, summation of all the discrete probabilities Pi natural log of Pi given Qi, right? This one. This is the formula. So the three discrete points are given. So it is a summation of all. So we can write it like 0.1 natural log of 0.1 divided by 0.2 plus we have to calculate for all the discrete values, so 0.3 ln 0.3 divided by 0.4 plus 0.6 natural log of 0.6 divided by 0.4. Okay, now we need to calculate 0 ln. Here if you just divide it, you will get 0.5. Here you will get 0.3 ln 0.75 plus 0.6 ln 1.5. Okay, so now further you have to find out ln 0.5 value, 0.75 and 0.1.5. So here if you just calculate, you will get, just calculate with the calculator, we will get minus 0.69315 for ln 5 plus 0.3 multiplied by minus 0.28768 plus 0.6 ln 1.5 value, you will get 0.4051 thing. So after that I'm just writing it here. Okay, so just multiply all these values, so you will get here minus 0.0699315 minus 0.0863 plus 0.2433. If you add all these values, you will get 0.0876. That is equal to 0.088. You can approximate it. Okay. So if you see that, option C is the correct answer for this question. Okay. So just you need to put all the i's values in this equation and find the values. Okay. Okay. So I hope you have got this question. Now moving to our next question. Now next question is related to the epipolar line LS. So consider a plane induced homography, that is H, and the epipole E dash for the stereo imaging setup. So homography matrix is given here. The epipole in the right image plane is given by homogeneous coordinates E dash, that is 1, 1, 1, and a point in the left image plane is given as x 2, 1, 1. Compute the homogeneous coordinate of the epipolar line L dash on which corresponding point of x will lie in the right image plane. So how we can calculate it? You must be calculated it in the previous classes or assignment problems. So I'm just taking the one new slide here. So have you remember this type of question from the fundamental matrix itself? So first here we need to calculate first skew symmetric matrix. Are you remember that one? So the epipole E dash is given. From the epipole E dash we can calculate the skew symmetric matrix, right? So the epipole E dash, we know that E dash is given as 1, 1, 1 transpose, it is given in the question here, and the left image point is also given. Now we need to calculate the corresponding right image point. So first we need to calculate the skew symmetric matrix. The skew symmetric matrix, and if you know that it is represented by this E dash S. So here this, it is calculated by, if you remember that one, it is already described. So 0 minus E3 dash E2 dash, the matrix is made from epipole E dash. So E3 dash here 0 minus E1 dash, right? Minus E3 dash here again E1 dash 0. Okay, so this is calculated. So just put all the values. So E3, so it is 1. All the values are 1. So just you can put 1. So here 1, 0, minus 1, minus 1, 1, 0. Okay. So this is the E1, this is E2, this is corresponding E3 value. Okay. So if the values are different, so just remember. So now we have to calculate the first fundamental matrix. So the fundamental matrix, how we can calculate the fundamental matrix? F. So F is calculated by this skew symmetric matrix multiplied by homogeneous matrix, right? So skew symmetric matrix we had calculated here already. 0, minus 1, 1, 1, 0, minus 1, again minus 1, 1, 0. And under homogeneous matrix is given in the here it is given 1, 0, 2, 0, 1, 3, 1, 0, 2, 0, 1, 3, and 0, 0, 1. Okay. So if you just multiply these two matrices, you will get here all the in this one first row, first column, first row. That if you just can I multiply or directly write? Okay, let's multiply first. 0 plus 0 plus 0 because 0 and 0 0. Similarly for the this one, this one, this one. Okay. So here in the next in this next column, first value you will get 0 minus 1 plus 0 again 0 minus 3 plus 1 1 plus 0 plus 0 here all the 0 you will get here 2 plus 0 minus 1. So here you will get minus 1 0 plus 0 0 plus 1 plus 0. Here you will get minus 2 plus 3 plus 0. Overall matrix you will get here 0 minus 1 minus 2 here 1 here 0 here 1 here, right? Here minus 1 1 and 1. So this is our fundamental matrix we have calculated. Now next we have to calculate the epipolar line L dash. So I'm just taking one more slide to calculate this. So the epipolar line is calculated by line L dash is calculated by fundamental matrix multiplied by x, right? So x that means left point, the image point is already given. So fundamental matrix that we have got 0 minus 1 minus 2
Can you
1.
go back to previous page
Yes,
of it?
yeah,
I just want to take a note of that.
okay, okay. Sure.
Yeah, thank you.
Yeah,
Done.
okay. Is it fine? Okay. So, okay, I'm just wanted to show you the x point. The left image plane x is given as 2, 1, 1. Now, we will at fundamental matrix by the image point. So, 2, 1, 1, right? Our fundamental matrix just completing it 1, 1, 1. So, if you just multiply these two, what you will get? So, just row, column, right? So, 0 minus 1 minus 2 here. Next one is 2 plus 0 plus 1. Next one is minus 2 plus 1 plus 1. That is equal to, if you just add, so here you will get minus 3, 3, and here all values will be the 0. All the cancelled out. Okay. So this value we have got for the epipolar line L dash. Now it is so just we will normalize it L dash. This if it is optional, so you can write it also if you want to normalize. So just divide it by minus 1 by 3. You can normalize it, otherwise you can leave it also. So here if you normalize it, the normalized value you will get 1 minus 1, 0. Okay. So L dash normalized value you will get 1 minus 1, 0. Okay. In the left. in its plane, this value you will get. So compute the homogeneous coordinates of the epipolar line L dash, which is corresponding the point X will lie in the right image plane. Okay, so this is the value. Okay, is it fine? Anything? Can we move to the next question?
Ma'am, how
Yes.
minus 1 by 3 for normalization?
You can normalize any value now. If you just multiply again back, uh, so you will get the same value minus 3, 3, 0. You can normalize with any value, right?
Okay, okay. Is 1 by
Yeah,
3 is okay?
yeah, minus 1 by 3. Just putting the 1 minus 1
To
because we
put
can
minus 1
form
by
in the,
3, if it take as positive, okay.
yeah.
Okay, okay.
So now again, moving to our next question. Okay, so our next question is related to color image processing. So here, the NTSC standard for calculating the luminance Y component from the RGB color is given by this formula. Okay, so if a pixel has normalized by the RGB value, that is RGB, the value is given as 0 0.8, 0 0.4, 0 0.2. What is its corresponding luminance? So already formula is given here. The NTSC standard for calculating the luminance component, the RGB color, is given by this formula, that is Y is equal to 0.299 R plus 0.587 G plus 0.114 B. And RGB values are given, so just put in this one 0.299 into 0.8 plus 0.587 multiplied by 0.4 plus 0.114 multiplied by 0.2. So if you just multiply, you will get 0.2392 here plus 0.2348 plus 0.0228. Here you will get 228. So if you add all these values, so you will get 0.5368. Okay, so which value is matching with this one? 5368. So if you see that, so 53 will two decimal places if you are 0.53, it is approximately. So option D is the correct answer for this question. Okay, it is the closest value 53 till two decimal places. That's right. We have chosen the option D is the correct answer for this question. So here already NTSC standard formula is given, RGB values is given. So just you have to calculate the luminance Y from the given RGB component. So just directly place it and calculate it. Okay, so simple. Okay, so it's a simple question. So I hope you have understand. So now moving to our next question now. Our next question is consider a surface patch in 3D space where the coefficient of the first fundamental form and the second fundamental form is given. That is first fundamental form EFG and this is our second fundamental form coefficient. Compute the mean curvature h of the surface at this point and answer to the two decimal places. So how we can calculate the mean curvature from the first fundamental form and second fundamental form? Have you remembered that formula? Okay. So mean curvature h, if you remember, is calculated by this one. E capital E small g plus capital G small e minus 2f f, right? 2 eg minus f square. Have you remembered that formula? Is a cap small f. Okay, to calculate the mean curvature from the 3D space, so all values are given. So just we need to put in this. So capital E is 4, small g is 6 plus capital G is 5, small e is 8 plus 2 multiplied by capital F is again 2 and small f is 0 here, and in the denominator e and g, so 4 into 5 minus f square, so 2 square. So if you just 24 40 here, if you just multiply, you will get 0, right? Here again 20 minus 4, right? So here you will get 64 and 2 multiplied by 16, right? So 16 4 just so 2, overall you will get 2 value, 2 you will get the mean curvature value is 2. So till 2 decimal places, so you can just put 0 0. If you see that option A is the correct answer for this question. Okay. So are you able to recall this type of this question? You must be solved this question. I think week 9 most probably. Okay. So I hope you are getting these questions. So now moving to our next question. Okay. So our next question is, which color space is most commonly used for image compression, like JPG image compression? Because it separates the perceptually important luminance, that is intensity, from the less insensitive luminance, that is color information, allowing the selective downsampling for color channel. Option A RGB, red, green, blue. Option B HSV, hue, saturation and value. Option C is YCB-CR model, or option D CIE flat. Which color space is most commonly used for image compression technique? Because it separates the perceptual importance, that is luminance, from the less sensitive luminance, color information. Which color space model we will use for image compression technique? You can say that. Any idea? Anything? Which image compression techniques we are using, or which color space model? Okay, so let's see the solution here. So here detailed solution for added for each of the color model. So first one is the RGB. So RGB is a device dependent and highly correlated, that does not make it sufficient for the compression technique. So this RGB is not used for color image compression technique. Our next is HSV. So it is useful for color manipulation and segmentation, but not for the compression techniques. Okay. Another one is a YCB-CR. So this color space that separates the intensity value, that is Y luminance, from the blue differences CB and red differences CR chrominance component, because human vision is much more sensitive to the changes in the brightness than the changes in the color. So the chrominance can be aggressively subsampled without the noticeable loss in the perceived quality, leading its significant file size reduction or compression. So YCV-CR is the most appropriate color compression technique, or image compression technique, that is it. And the CIE lab is designed for perceptual uniformity, measuring how colors look to human, but not standard choice for lossy compression schemes. The correct answer is C. YCV-CR techniques used for the image compression, like JPG or PNG. So YCV-CR model has been used. Okay. So now moving to our next And last question. So a 2 cross 2, 256 cross 256 range image is captured by a LiDAR sensor. A standard 256 cross 256 color image is captured by a convenient camera. What information does the value stored at a pixel location xy represent the range image that is fundamentally missing in the color image? So option A, the average brightness, that is intensity. Option B, the texture and surface shading of the object. Or option C, the direct physical distance depth from the sensor to the object. Or option D, pixels location in 3D space. So here 256 cross 256. One range image is captured by LiDAR and another one is a standard 256 cross 256 color image captured by camera. So they are asking what information does the value stored at the pixel location XY represents in a range image as well as the that is fundamentally missing in the color image. Okay, so let's see the solution, detailed solution given here. So range image that has been captured by a LiDAR sensor. So a range image is a 2D representation of the 3D LiDAR point cloud, as we know that. So at each pixel location xy, the stored value represents the distance, that is depth. That we have solved the one problem on that also, calculating the depth. From the LiDAR sensor to the corresponding point of on an object in the scene, the LiDAR sensor uses the laser pulses and measure the time it takes each pulse to bounce back from the object to calculate its distance. Okay, so this gives the image the third dimension, that is the depth, that is not available to the standard color image plus image. Or while a color image, that is conventional image, a conventional capture camera image is captured by light reflected from the object. Already we know that. For 256 cross 256 color image, each pixel XY stored information about the intensity and color of the light that hits the sensor at that location. So this is typically represented using the three-value RGB color channel, and while the image provides this details about object appearance, including brightness and color, it does not contain direct information about how far away the object it is. Okay, so LiDAR sensor provides the distance at that point. Okay, so other options are the average brightness, that is intensity, that is a color image contains brightness information, and monochrome camera capture intensity exclusively, while the range image can also include the intensity channel, the strength of the laser reflection, and depth value itself, what is a fundamental unique to the range image. So it is stored by both color image as well as LiDAR sensor. And next one is the texture and surface shading of the object. So in the conventional image is excellent at capturing texture and surface shading, which is a result how light reflection with the object surface. And in a LiDAR range, image does not capture the visual data while LiDAR. And the other one is the pixel's location at in 3D space. While the range image can be used to reconstruct 3D point cloud, the value at the XY pixel directly represents only the distance. The full 3D location requires combining the depth value with the camera angles and location, but the information fundamentally missing from the color image is the depth itself. So correct answer for this question is answer option is C, the direct physical distance depth from the sensor to the object. That is the missing in the color image. So at the point xy, pixel location xy, that the distance is present in the range image and it is missing from the color image. Okay. Okay. So these are the questions that we have covered over the weeks. So thank you everyone. Thank you for joining this session. So now my questions have been completed. If you have any doubt, you can ask now. And
Thank you, madam. Thank you very much.
Thank
yeah,
you, madam.
thank you everyone. Thank you for joining this session. And all the best to your exam. Today is our good night, good night. So today is our last session, and now all the big questions and assignments I think you have completed. I have gone through this week's
Yes, ma'am.
video lectures. Have you understood it and practiced many problems from the three sessions, extra sessions? So this is our last session now, and I will wish you all the best and all the luck to
Thank you
all of
so
you.
much, ma'am.
All
Thank
the
you so
best
much.
for your exam. If you don't have any doubt, now we can close the session.
Madam, can we mail you any doubt, any mail ID of you or any YouTube channel do
Okay,
you
okay.
have?
YouTube channel, I have that already. We have shared the in the recording sheet, right?
Okay.
There you can mail. Otherwise, okay, let me share that one.
Yeah, yeah.
Uh,
Please share your personal mail ID, ma'am. That will reach you better, I think so.
yes. Okay, okay, I will share here.
There will,
So this
there will
is a link of the recording session where you will get all the questions PDF and
yes,
the
ma'am.
YouTube link that whatever session we are taking. And okay, my mail ID is there. Okay, this is my email ID. You can mail here also if you have any doubt
Ready,
anything.
urgent kara. Chinni, urgent kara penade. Varma @
Ma'am, did you give any tips for preparation, ma'am?
Okay, any
Because we
tips?
have
Mm,
12 assignment week questions, and also
mm,
your question setup in every problem solving session, and now
yes, yes.
also some 25 questions.
Yeah, okay. So just remember the main key points for each week. Just, I mean, you can make a notes for each week wise, I mean, main key concepts and the key. So they see most of the problems are, I think, same, right? In the all the weeks. If you just go through the all week assignment problems and questions, so you will see some concept concepts are similar. Just you remember that concept and formulas and just apply the question. Values are different, right?
Yes, yes, yes.
So just remember all the key concepts. Just main key how you can solve what is a procedure like KNN or PCA, LDA. Just remember what is the procedure to solve any question. Just stick with the fundamentals. I will suggest you because there is a other many chances to you get different set of questions. Just stick with the fundamental. I would say. Just remember main key important points. What are the week-wise important key important questions or important concepts? Just go through. So I have solved many conceptual problems as well. So just if you see that here, the last question, right? This is also a very conceptual question.
Yes,
It is
yes.
related to the range image processing as well as color image processing. So very basic question कि what is the difference between the range image मतलब what information is missing in the color image and what information is present in the range image. So just remember these basic points. And some other questions also I have that is related to very basic or a fundamental. So that type of question maybe they ask like this one also, which techniques you will use in the image compression techniques, something like that. And these all these things so are also related to the key fundamentals or key details, right? So I would not suggest you that you will go just solve as many questions as you can solve, but I would suggest just stick with the fundamental or key details of each concept. Some you but you must be notice some important topics or concepts also, right? What are the important topics? Like they may be asked one question from PCA-LDA, one question from clustering or dimensional reduction, that is same. And they must ask one question that fundamental matrix and epipolar line, stereogeometry. So just go through that all these concepts. Just remember there are one or two problems, two types of problems are mainly they have focused. So just remember all that those points. Okay.
Okay, ma'am. Thank you.
Okay. So thank you, everyone. Thank you for joining this session. Now can we close the session?
Thank you so much,
Yeah.
ma'am.
Yeah.
Good
Thank
night.
you.
Good night, ma'am.
Good night. Good night. Thank you, everyone.
Bye
Thank you
bye.
for joining this session. Now all the best for your exams. Yeah. Yeah. Good night. Good night.
She is Jia Bhanu, ma'am. Class second.
Oh, yeah. Yeah. You told.
Thank you so much,
Mm,
ma'am.
yeah. Thank you.
Himanshi
Okay,
Dipta.
now if you don't have doubts, now you may leave the session. Then we
Yeah,
will
it's okay,
close.
ma'am.
Okay.
We'll leave the class.
Ma'am, similarly, other two scholars also taking the class.
Yes. They will also take the extra summary
Okay.
session that will be there.
Okay. Okay.
Yeah. Any doubt? Any other thing? Anything that you wanted to ask? Swati, is there any doubt? Anything you wanted to ask?
No, ma'am, I'm clear. I'll mail you if required.
Okay,
Thank you.
okay, okay. Oh yeah, thank you. Now you may leave the session. Okay, thank you, thank you.
Sure. Thank you.
Yeah, thank you everyone. Thank you for joining the session. Now we will close the session.